Hello, hello again, Jawad Alzeer. Today, I think, this is the video where I would like to go back to chemistry because in the end, we started with chemistry question, we will end up with chemistry questions. I will not give you details about those answers, but it is like a starting point to understand chemistry from different perspective. In the previous videos, we learn the connection between entropy and potential energy. We learned the duality concepts, and we saw how if we could implement this correctly in our body, we can create beautiful balance. And this balance is so useful in maintaining homeostasis. And now we will come again back to the concept of duality, but in the context of chemical reaction. I would like to discuss the mechanism of well-known reactions, SN1 and SN2. Now, we all learn SN1 and SN2 in organic chemistry classes, and we always explain that SN1, usually tertiary carbon attached to leaving group, dissociate to generate a cation which is stable because of the steric hindrance, create a stable tertiary cation, and then generate product, whereas primary in SN2, primary carbon, which is attached to leaving group, cannot generate a stable cation, and therefore it doesn't dissociate, but it goes in a different mechanism, which is called SN2. So the association between leaving group and nucleophile. Now let's look at this concept or this question from different perspective, which is potential energy and entropy. Now, if we look at the tertiary carbon, which is attached to the leaving group, you will see this carbon is highly branched. And because it is highly branched, so I would say it has more potential. Potential is high, flexibility is low. Flexibility has to do with entropy. Rigidity has to do with potential. So it's more rigid and less flexible. So what is missing basically is flexibility in the tertiary carbon. And to generate a product, it has to go through a transition state where it can increase flexibility or increase entropy. That's why in SN1 reaction, first it dissociate, and then it generate more flexible moiety, which is the cation. And now here we create more flexibility, which is basically needed for this reaction to proceed further, and then we end up with a product. Now in case of the SN2 reaction, it's really reversed. So primary carbon, which is attached to the leaving group, usually it has more flexibility, but it is missing rigidity, which is potential. So potential is missing, entropy is there. So during the reaction, so the transition state, during transition state, you will see this primary carbon build potential, and that's why it associates with the nucleophile, and this association help in building potential which was missing in the starting material, and then transfer into the product. So I don't know if this is coincident or not, so you chemistry students can tell me, and probably if you work later on in research you can prove me if I am wrong or not. But it's so interesting to understand the optimal reactivity of each molecule. So if this molecule has high potential and missing flexibility, so to make this reaction possible, we just have to induce flexibility. On the contrary, if the starting material has so much flexibility, if you want to transfer this into a product, we have to induce some potential, some rigidity. And now if you see in this example where we have a bicyclic, it is a locked molecule. You see the leaving group is attached to carbon. It is tertiary, right? One would think, oh yeah, this is the best orientation for SN1 reaction. But in reality, this reaction will never work. Why? Because from potential perspective, it is there. So this molecule, it has very high potential, but there is no flexibility. And we cannot even generate flexibility because it is locked. And as long as it is locked, there is no way to induce flexibility or to induce entropy. And that is why, if you look at these type of reactions and you see that it is impossible to generate or to induce flexibility, you will come quickly to conclusion that this reaction will never take place. And in practice, this reaction neither take place in SN1 nor in SN2. So this is, I just wanted to explain for you, if we introduce the concept of duality, potential energy and entropy, and then we can understand the optimal reactivity of the molecule, and maybe on the long run we can understand the optimal biological activity of the molecule, and hopefully medicinal chemists will try to work in that direction and find out if this is essential or not. Thanks again, wish you best of luck, and hopefully this source of videos were an excellent source of help for you. And let me know if you have any questions or to come back with a new idea to explain something in more detail. I'll be happy to do this. Otherwise, wish you best of luck.